Oh, wow. All these people here. What are you doing here? It's Friday afternoon. It's 28 degrees. You should be sitting outside. You're all watching me die here on stage. All right, let's see if this works. Yes, it works. Okay, getting a grip on your dependencies. Well, my dependency was my laptop, which failed me, which is usually something that happens with dependencies. They fail you. So this is a good exercise, a learning exercise. It's my last day in Sydney, so I can die in my plane tonight. Thank you for showing up. Dependency management. It's all about coupling, right? It's all about coupling. Now, the main question people always ask me is like, how do I prevent coupling, Dennis? You build an open source library and you're supposedly very smart. I said, well, it's all fake until you make it. But yeah, how do you prevent that? Well, typically, there's a couple of answers. One of them is don't write code at all, then you don't have the problem. Or use a programming language that doesn't have this problem, maybe JavaScript. Oh no, it has NPM, that has NPM. No, not having. Maybe write code in SQL, PL SQL and Oracle or something. They don't have any packages or dependencies or whatever, I guess. But yeah, usually the answer is, you need to increase cohesion. You need to decrease coupling. By the way, I'm moving too close to my microphone. Okay, great. That sounds like the ultimate answer, but how do I do that? I mean, that sounds so awesome. That's something you hear in every conference that talks about architecture, increase cohesion, decrease coupling. So you need to put stuff together, but I also need to decouple things somehow. How does that then work? I don't know. Usually we do that. Wait, did I skip a slide? Yeah. Usually we do that by introducing abstractions, interfaces, contracts and stuff like that. But I don't know, I'm trying to gauge the experience level. I guess there's more than one person in this group that has created too many abstractions, or creating abstractions that sounded like a great idea because you were trying to make things simple for the new people in the team. Ultimately, it became really convoluted and difficult to understand. You all know Yagni. Especially if you just came from a university or something like that, you tend to create all these. You read a book about design patterns, for example. What do you do when you remember that? Did anybody read the book just to check? Old enough? Or the webpage these days? Or is there a TikTok variant of that or something? I don't know. But I remember when I read the blue book, I had the physical copy. What did I do? This is awesome. I'll bring it to my desk. I'll show it to all my colleagues. I was physically on my desk when we still physically went to the office, like, in ancient past. And then it became almost like a bingo card. Like, I've never actually applied the visitor pattern. Anybody applied the visitor pattern as a serious thing, not for fun? Yes, Chris, you did? One time. Was there a legal reason for doing it? So that's the thing, all these abstractions, they make things usually more complicated than we want to. And we all go through this cycle. Somebody on Twitter once said, and I'm going off script again, doesn't matter, it's Friday afternoon. It's very cozy here. I remember that somebody said if you have 10 to 15 years of experience, you tend to be the most dogmatic person. Only after that, you start to realize that every principle, and I see people with almost no hair shaking, yes, I recognize that. Don't look at people. You realize that every principle, pattern, practice has pros and cons, and you need to understand the context in which those apply and which not. They're all great things. Everything, I practice test-driven development. I love it. I've done it wrong. I'm trying to do it right now. I'd like to think I do that right. This applies with everything. So abstractions have their place. So, too many abstractions. And I don't know if you've ever heard about that. I think somebody said once that there's not a problem you cannot solve with another abstraction except the problem of too many abstractions. It's very old. It's when people create things. Now, cohesion is to make sure that everything around a particular concept is in one place only. So how do you increase cohesion in your code base? It's an open question. There's no stupid answer, sorry. No? Try. That's what you learn, right? Don't you remember the first time you create some code and then the senior developer, there were no pull requests at that time. Maybe you still experience that, tells you, yeah, but we already have an implementation like that. Or almost like that. Make sure that we can reuse that. Yeah, but it's not like doing the exact same thing. No, but we do not want to have the same logic twice in our code base. So we're going to refactor it. Yeah, but it's not doing the exact same thing. Okay, then we make it, make it more generic, make it more flexible so we can actually reuse that code. And that becomes almost like, yeah, but we follow dry. We do not repeat ourselves. That's against the rules, And we've all done that. I'm still doing it. And what's the flip side of that? If everything is in one place only and everything depends on that. Coupling, indeed, that's the problem. So dry is a very good thing, but it can lead to too much coupling. And yeah, I've experienced this firsthand. So then what is the solution? What is the solution? Well, Yoda is very old. Actually, he died a long time ago, kind of. It's actually pretty simple. Understand the internal boundaries of your system. Okay, Dennis, that makes sense. No, it doesn't make sense at all. I have no clue what you mean. What boundaries you're talking about? Yeah, that's the difficult part. And that's what I'm going to help you with the rest of the talk. Check the time. Yes. Okay. Internal boundaries. How do you know what the internal boundaries are of your code base? Well, it depends. If you have a very nice, well-organized code base with modules and internal seams and nice abstractions, it's pretty obvious. So let me ask you an honest question. Who has a code base? Who's currently working on a code base that feels like it's well-structured, completely consistent? Everybody knows where the code is. Honestly. People are afraid to say yes because they're afraid no. It happens. It happens. Even my own open source project is, I would say, a bit messy. But as we just discussed, I have a slight form of OCD, I think, or I'd like to make fun of it. Anyway, by the way, I completely forgot to talk about myself because I love talking. I'm Dutch. You can probably hear that from my accent. So I flew all the 24 hours back. So I'm adjusted now to this time zone. And tonight at 4 o'clock, I have to go back to the airport. I like to call myself a hands-on architect in the .NET space. I've been in this profession for 27 years. I started coding on a Commodore 64 when I was 11 in assembly and later C, C++, and then I discovered C#. I do look a little bit around it, like languages that look a little bit the same, like TypeScript. And I typically help my clients to optimize the entire development process from ID to production, continuous deployment, Pulumi, test-driven development, architecture, event sourcing, a lot of this stuff. I've been an MVP, Microsoft MVP for a year now. I'm up for renewal. I have no clue what it means or whether I will succeed. I will lose all these nice licenses. And you can find me on Doomen. That's my Twitter. X handler. Doesn't work, X. Anyway, I have a couple of things, a blog. I have coding guidelines. I have one more. A couple of libraries for event sourcing, a BDD style framework I maintain. And you may know me from Fluent to Search. Anybody in the .NET space here? I'm always surprised, like half of the people are not. So they're either front-end developers, managers, architects, Python, data scientists. No, okay. Difficult. Very difficult audience. Anyway, if you do know it, then you probably know this stuff, which does not define me for the people that do know that. Fluent to Search is just a library and it doesn't say anything about architecture. Well, understanding the internal boundaries is very hard. So the first thing is what you need to do is try to understand that code base. And there's a couple of things you can do. You can, for example, use the project dependencies or folder names or namespaces in your C# to get a sense of what are these things? How is this code distributed across this big code base? If you're in Java, it's probably package names or something like that. They have a similar concept. I typically use this. This is from my own open source library. And what you find is, you cannot see this on the back, but the folder names are typically very functional. If you have that, that helps. But if they're very technical, like Microsoft, if you create a project, you get like an ASP.NET web project, you typically get things like controllers, views, models, repositories. That doesn't tell you anything about the functional structure of that code base. Only there's technical concepts there. That doesn't help. You can use all kinds of tools, like this is a project dependency view. Every platform has something similar, which helps you understand the thickness of the error actually means how thick the coupling is, how thick the dependency is, which is nice. This is a type dependency diagram. It's completely unreadable. It's also unreadable here. It doesn't really matter. But it's a tool that hopefully gives you some insights. You can use Ndepend, which is another one. It's a paid product within the .NET space, which is very powerful because it also allows you to visually group things in a way that makes more sense. But it's all about understanding the code base. I remember that I had to work on a legacy code base with one of the teams of my client. And I was wondering, like, what's the scope of those unit tests? They were really weird. Like, some tests were actually interacting with the controller, which is an ASP.NET HTTP class, but also interacting with the database. And I was trying to understand, like, what actually made them decide to have that kind of scope? It turns out that code base was an onion architecture, and I'll talk about that in a second. They didn't realize it. Nobody in the team knew what the architecture looked like. They had no clue. They were just looking at, projects and code and just mimicking what other people did. That didn't help. So I actually draw a picture for them, because pictures tell more than 1,000 words or something, although I can speak very fast if I want to. But that helped, because they suddenly started to get this mental picture of how things are supposed to relate to each other. So tools like this can help. You can also use your IDE. If you have a good IDE, it can also tell you all kinds of stuff, like where does a parameter come from, how does the decall chain go over the different classes or modules or whatever folder structure you have. Gives you an indication of how things are supposed to work together. There's an example that JetBrains Writer does, which is the .NET development tool from JetBrains. There's lots of other examples that you can use. Use those tools. Don't use Visual Studio Code for coding. That's a text editor with some smart things. Use an actual IDE that provides that insight. So that's important. And it's 2024, AI is everything, and I should have an AI slide, otherwise I'm not part of the hype. Use AI tooling. Now, I'm actually a big fan of AI. Like, again, this is JetBrains. They have all these IDEs now. All of them have built-in AI support, which can do things like explain that code. I actually discovered a production issue where somebody actually implemented an RSI, asymmetric encryption by copying code from the internet, which I couldn't read. And it was using padding. I have no clue what padding is. And actually, I used the AI to explain what that code was doing, and it detected the algorithm, even provided me with an alternative. That by itself has saved me weeks of work. So use that, Here, this is the chat, shows you all kinds of stuff, explains your problems in your code base. That can help. The tools are incredibly smart. I have no clue how it works, but it has helped me tremendously. Yes, so AI tooling also use it. The first level where you need to control your dependencies on the architecture level. That's where it all starts, of course. So what I like is to rely on the dependency inversion principle. I know everybody knows solid, right? Solid? Yes? No? Oh, only 2 people? Really? Single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, dependency inversion principle. No? Okay. Who's your architect here? Just checking. Nobody raises their hands anymore. No. I don't blame you. It's actually pretty simple. I have an interface. I don't know if you can see that in the back. It's called iStoreOrders. It's a generic interface, which is something that C# has. And it has a couple of methods. Query, add, delete. Is this a generic interface in a sense, like, is this generic functionality, or is this very specific to the domain you're working in? Generic or to specific? Who thinks it's generic? It's pretty generic, yeah? Or who thinks it's specific? Who doesn't think anything because it's Friday afternoon and yeah. It's very generic. Because, yeah, I mean, and not to be confused with .NET's generic concept, but it's a generic thing. You can do anything with it. I mean, yes, it can store orders, but you can build complete queries, and there's not much you can optimize. So imagine there's an implementation. In this case, it's a repository pattern on Hibernate, which used to be popular in the .NET space. And then we have this functional module, an order processing module. That is very domain specific, right? It's a blue, it's in a domain layer. And this is typically how it works. That's how you do that, right? Everybody has implemented a repository pattern at some point in their life. Yes, see. This is, I was going to say wrong, but I should be more subtle. It's wrong. What the dependency inversion principle does, well, it's kind of self-explanatory. It reverses the dependency. What does that mean? Well, I still have the same module here, order processing. The difference now is, what's the difference? It's blue, not yellow anymore. No, actually, there's another, it's actually more functional. The names in there are now called get incomplete order or store order or complete an order, which is much more functional. The difference is now the order repository is still there. We still have this, I don't know what it's called, an Hibernate or anti-framework or whatever you're using in your space. But notice the dependency, it goes upward. So now what you have is that the domain layer has defined what it needs. It defines a contract, what it needs. And then the lower level layer, the data layer, if you like to use a layered architecture, is actually implementing that contract. And we almost always do it the other way around. We always have this dependency to these generic pieces of code that we create. This is a very powerful technique that you can use to decouple code from each other. It can be confusing, and intuitive in the beginning. And the Dependency Inversion Principle, actually, if you read Uncle Bob's book, it says something like higher level abstraction should not depend on lower level abstractions, which by itself sounds very abstract, which we're trying to avoid. But yeah, that's kind of the idea. Now, you can also apply this on the architecture level. This is an example of the onion architecture. By the way, I don't know if anybody went to Ian Cooper's presentation. I'm not suggesting that you should use the onion architecture without understanding the problem, because it's an architecture style that has pros and cons. You need to understand that context. You need to have the problem that this style tries to implement. Some people would even say it's outdated, but I guess there's a lot of people that haven't even seen it yet and are still trying to figure it out. It's still a layered architecture, but the beauty of this architecture is that the dependencies go inward. So the domain model is in the middle, does not have any dependencies. If the domain model needs to somehow be able to persist the domain or get information from the rest of the world, the domain model will define this. So the center circle will define what it needs, a contract, what you just saw, and then the outer layers will actually implement that contract. So if you have a complicated architecture and you need some kind of structure, this is an option. But you need to understand, read more about it. I'm, again, not saying that you should blindly follow. This is another version, the hexagonal, I cannot even pronounce it. How do you pronounce it? You're American. Hexagonal. Cool. Nailed it. It was an intense week, let's call it like that. But also ports and adapters, that's the other term. It's kind of the same idea. Domain is in the middle, application is around it, and you have all these primary and secondary ports that are supposed to connect your system to the rest of the world, to the database, to the UI, to HTTP endpoints, whatever. Same principle, because the dependencies go inward. This is another version. This is Uncle Bob's version, but yeah, it looks exactly the same, just different terminology. Errors go inward. This is what you can do on the architecture level. Again, these are not top-level architectures. These are styles that you can apply to a part of the system if that part of the system has certain requirements that warrant this architecture. I've done a lot of event sourcing in my career. I love that architecture style, but it's not something you should just apply unless you have the problem. A simple CRUD architecture is still completely fine. What is important, and this is not to be confused with a vertical slice architecture, because that's also controversial, but I do like to organize my code and my functionality into vertical slices. So is the vertical slice? Yeah, probably it is. Yeah. But I like this model. It's very easy to draw. That's the beauty about an architecture. You can draw nice architectures with nice boxes, nice boundaries, and then you hope that the developers implement that. That's why I'm a coding architecture. I help them. But what you see is basically everything is organized in a functional aspect. Every of those slices may have a different architecture style. Maybe the first one, I have to stay with the microphone. The first one has onion architecture because it's a very complicated domain. Maybe the second one is a very collaborative domain that needs high performance and where we want to be able to have multiple people work on the same entity. Where you want to merge events, you would apply event sourcing. Maybe one of those slices is all about, searching, and you use a simple Lucene index or Solar or whatever, and it's a very simple architecture. That's the whole point. All of them are supposed to represent capabilities that the system provides. And of course, you immediately see that the dark orange part, assuming that they're not colorblind, are the seams, are those internal boundaries. These become natural boundaries. Composition, it's a bit of a puristic approach, is where you connect everything together. So if the first slice needs some surface from the others, it would define a contract, and then the composition layer would connect the two things together, which is kind of a, the moderator? Moderator pattern, yes. There's still shared services, because you should apply dry within boundaries. But this is important. Oh, so dry, as I said earlier, is a good thing. But you have to be careful that you don't apply it dogmatically. So what I like to do is, given those boundaries, those capabilities that I have in my system, and then I even structure my code according to this. You can actually go to the repository and you'll find the names of the specific functional slices, literally a composition, shared services. You can actually see from the code base what the architecture looks like. Some people will call this the screaming architecture. The code base screams the architecture. I hope it's not screaming because of pains, but screaming because it's happy or something. So dry, I actually apply within those boundaries. So let's say I have some kind of surface, which can be anything, most conceptual concept, some reusable piece of code. I typically just duplicate the thing across the different slices, even in the same repository. Yes, I do that. And that feels very unnatural to a lot of people, especially if you have to explain this to your architect. Like, why are you duplicating the code? Sonar Cloud now reports we are across the 12% duplication. Turn it off. It's bullshit. It doesn't help at all. It only leads to more coupling. A couple of more examples. Duplicating service 2 is also duplicating across the code base. Helpers, whatever you call helpers. And if you're in the .NET space, you love extension methods. You know, C# is extension method, which allows you to extend every method, every class with additional capability. I built an entire library with 300 million downloads. It's everywhere. I also duplicate them. Wait, what? So you're basically duplicating everything? No. I actually think about what is worth duplicating and what is not worth duplicating, what is too difficult. So there's certain things which I put in a centralized service. If there's certain functionality that is either very complicated or needs certain skills to understand or maintain, I might actually decide to put that in the centralized service, create an interface, and make it available to the rest of the code base. So it's not like one end of the skill or the other. That's being dogmatic. I'm trying to, case by case, figure out what should be reused and what should not be reused. Make sense? Interesting thing is, if you have this whole architecture, suddenly the question about what is the unit in unit testing also becomes much more, I would say, natural. You know, the books will probably tell you that if you do unit testing, or even better, test-driven development, every method, every class is a unit. And if you follow the books blindly, you'll probably design it like that. I completely disagree with that. I'm not very opinionated. Well, I'm very opinionated, loosely held, I'd like to say. Actually, this becomes quite obvious. So if you look at this picture, there's a couple of servers here. I would probably create unit tests around the entire slice here, if that makes sense. Other slices as well. You know, this one also, I'll create tests around them. And technically, that's pretty easy to do these days. Those tests don't have to be very complicated and difficult to read. Since there's a couple of things which are within that slice supposed to be reusable, I call them services here, again, in the most broad term. I test them separately. Here, the service on the right. There's another one here. And of course, the centralized service is also tested independently. Those are my units. And that actually, so if you try to practice test-driven development, and Chris had a great demo yesterday about it, the way you can do it wrong is if you treat every class and method as a separate unit. You tend to create tons of unit tests. You know, you have very high code coverage, but whenever you redesign or refactor something, because we should do that, that's what we do every day, you'll run into the situation that you have to rewrite your tests. That is a smell. That's a signal that you're probably testing too small. Of course, you can also go to the other end of the scale, you're testing too big. I've also experienced that. But understanding those internal boundaries actually helps you with this kind of stuff. This is the architecture level. On the package level, and whenever I say package, you should assume I'm also talking about projects within a solution or components in a different architecture style. You also have rules to make that easier. Who has this problem, experienced this problem that you update a package, whether it's a NuGet package or, I don't know, PHP or NPM, and that pulls in a whole bunch of other packages? Who knows that? Who has experienced this? Everybody's coding. The rest wasn't coding. Still wondering what they do. I'll ask afterwards. This is not the coolest room, so I'm not sure why you're here. But this is a problem. But it's even worse if you depend on two different packages that depend on a shared package, and then the functions start to deviate, like even breaking changes. You're basically screwed, right? And there's ways to work around it, but it's always painful. There's an easy way around that, relatively. What I do, and this is based on a book, this is also actually Robert C. Martin also wrote about this. And there's another book called The Principles of Successful Package Management. written by a Dutch guy, I think Matthias Nubak or something. He says, create a package. Great. We can all do that. Instead of creating very generic base classes, you know, we love to have these libraries. You create a base class, you derive from it, and somehow all kinds of magic happens. You don't know what's happening under the hood, but it works, right? The problem with most of the time is if you have that and you want something that the magic doesn't provide out of the box, you need to dive into the details. Quite often, it's either very difficult, not documented, because the author of that package only focused on the most common scenarios. So I take the opposite direction. What I do is actually create small building blocks that all serve their own purpose, that you have to understand. Even my documentation is written like that. And then, if you cover this part, I actually provide some kind of higher level building blocks, base classes, no, not really, but convenience blocks that will make it easier to solve the most common scenarios. But you need to understand the individual bits and pieces. They're also properly documented. The tutorials start with this. For example, the library liquid projection that I just showed you quickly, which is an event sourcing library, is built completely according to this idea. This is step one. They don't hide the magic. They don't hide how everything works on the hood. That's important. The application, whatever it is, does not use inheritance. Wait, we've actually been told, right, with object-oriented programming, inheritance, that's the holy grail of programming these days. Well, yes, maybe it is, but it's also something that leads to coupling, leads to super classes, super base classes, God classes, some people like to call them. It's not because we're bad developers, it's just organically these things grow in a certain direction. And that's why I try to avoid that. So I prefer composition, basically using building blocks in other classes instead of deriving from building blocks. That already makes it a little bit easier, creates more decoupling in there. Next step is make sure you only depend on abstract packages. Why? What's so specific about abstract packages? I was actually hoping for interaction today. Sorry. They can be replaced, yeah, that's true. Well, the most important aspect is they tend to be stable. Abstract interfaces and contracts typically don't change that much. Like, so Newtonsoft.json is not a good example in .NET space of an abstract stable package that changes so much. Of course, it becomes obsolete now that Microsoft replaced it. No, as long as you depend only on packages that, for example, define interfaces or contracts, or packages that are very specific and only contain small pieces of functionality, then the ripple effect is reduced. And this is pretty fundamental. The next time you go back to, like next Monday, if you start working on, try to think about all the dependencies and how you distributed the logic around across the different projects. Again, package means project, component, microservice even, but that skill you can think about that like that. Also, if you have like additional functionality that is not always used with the main package, don't put it in the main package, actually create a separate package out of that. So in this picture, you see this blue box, dependency package, which actually decouples the two of them. It's almost the dependency inversion principle again. The optional package depends on the core one and connects it to this other capability that you have. That's another principle. And everything that's in that package is something you should use at the same time. So additional stuff, like, I don't know, you build a library that has some mock implementations for unit testing. Don't put them in the same package, put them in an auxiliary package. If you're in a .NET space, XUnit is actually doing this. You have XUnit abstractions, XUnit core, XUnit other stuff, assertions or something like that. That's done on purpose to decouple things because you do not want to ship a new version of your core package just because you changed the mock implementation and made it a bit smaller. Nothing changed in the rest. So you actually end up much more controlled versioning of individual packages and components. It sounds very difficult. No, it's cool. That's actually cool. I know cyclic dependencies, obviously, but nobody does that. Let it sink in. Next week, try to look at the picture again, look at your own code base and try to get a sense like, okay, maybe I get it. If you don't get it, you can always reach out to me. You can hire me or something. I don't know. No, it's too far away. On the code level, yeah, you can go one level down. On the code level, same principles. What can you do? In .NET, if you create a class or a struct or whatever, the default visibility, so the scope of how you can access it, is unfortunately public. which means that if the code is public, anybody can use it, which is annoying because then it means also IDEs like a writer or a resharper, they cannot actually make any assumptions whether that code is being used. Even if that code is not even invoked within the code base, and if it's a big code base, you may not have that overview anymore. It can't make assumption because it's public. So the first thing I do is make everything internal. Internal in .NET means it's only visible within the same project or the same package, which makes a difference. Now, the IDE can actually can reason about that. It can actually analyze the code base and discover, hey, you're not calling this. It becomes gray. And what's the best day as a developer in your life? Deleting code. I was going to say getting a pay raise, but no, actually, that was my point. Deleting code is awesome, especially if it's other people's code. Because then I can rewrite it. No, I love deleting code, even deleting my own code. Because every line of code that is not there, I don't have to maintain, don't have to create tests for it. Unless you have nothing left, then it's no fun anymore. But anyway, but this is important. It's a simple trick. Make everything internal, and I don't know the equivalent in other languages, but figure it out, but you know what it means. Remove unused code. Well, clear. Even unused parameters. It's surprisingly much. Like every code base I've worked with as a consultant, if I use the proper tooling, you know, all this stuff becomes gray. Like entire section of the code where the compiler didn't actually see it, but a good analysis tool can actually figure out like, hey, this section will never be invoked. Just delete that. It's incredible how much code I removed from my last project I rewrote. What else? I already alluded to that. If you start to structure your code base according to the capabilities, then make sure you do the same with your code itself. So this is an example, and this is a pretty puristic example, where I have a component that is responsible for making a distributed log across different servers. It's using SQL Server specific primitives to make sure that only one of the servers at startup can, for example, initialize the schema of the database. That is something that I do not want to duplicate. That is a good example of something I would put in this, you know, the bottom part, the shared services. What's interesting is I have an infrastructure folder, which is debatable. It has a functional name, distributed logging, which is what it's about. It has an interface called I provide cluster-wide log, which is a .NET convention to say I provide to you a cluster-wide log. It's an interface, abstraction, and a concrete implementation, the cluster-wide log provider, obviously. But what's interesting is there's also code in an internals folder. And that code, if you're in the .NET space, might actually look very generic. I mean, who wants to create an exception swallowing disposable? It's a pretty special thing. But the point is, I make it very explicit here, almost puristically, that some of this code is just an implementation detail, even though in the past, I would probably put this into infrastructure common or something like that, some generic name so I can reuse code. I'm not doing that. I'm just duplicating it and make sure that this is internal. Why do I use this? In .NET, the default behavior is the namespace, or sorry, the folder structure is also the structure of the namespace of your types. So if somebody accidentally, because the IDE is very easy to import all kinds of stuff in your current code base, is using at the top of the file, using as a way to import a namespace, same principle as import in JavaScript and TypeScript, infrastructure.distributelogging.internals, that's hopefully a signal for the reviewer, like, hey, that's weird. Why are you using internal stuff from a completely different namespace? It's to reduce coupling again. You know, yeah, but you know, we need to apply dry. No, not at this level. By the way, this also becomes almost a natural seam, the natural boundary for unit testing. For dry, I already showed you for unit testing. It's so simple on paper. Also means that the JSON folders in your structure are supposed to be separate, separate boundaries. So that's why I hate the whole principle that Microsoft have, the controllers, views, models. They are usually part of the same thing. One controller in ASP.NET links to the view, links to the model. They belong together. These models are typically not reusable. So group them in the same folder. That makes it much more logic how things belong together. And it means if you have things in separate folders next to each other, that means that in principle, a separate unit for unit testing and for dry and for other things. I hope that makes sense. A couple other things. Tell, don't ask principle. Like, what's wrong with it for the first line? order.orderlines, any has a value of more than 10K. What we're really trying to do here is, for the sake of time, I'm not actually going to wait for the answer because then we're not finished before dinner. What we're doing here actually is saying, I want to know if this order has a value of more than 10K. Why is this code touching the order lines of an order and doing this yourself? Why is it not just asking like, are you high valued or something like that? That's a basic OO principle, data hiding. And still, we all do this. Why? Because we simply often use primitive types for collections instead of encapsulating this. So the bottom one is the correct one. I'm asking the order, are you high valued? Because if that logic changes, none of the rest of the code needs to know about this. Same here. If the item sell in is smaller than 11, if the item quality, then we increase the quality. So you're basically putting all this responsibility, and I don't know what kind of business rule this is, outside the class or the type that owns this information. This is so trivial, and we all do it, including myself, because it just sneaks into your code base. You have a collection. You're using certain methods to iterate over the collections. Putting everything back into the class, applying basic OO principles, except inheritance, of course, makes this a lot easier. The law of Demeter, do I say Demeter or Demeter? What is it? Is it Demeter? Or depending on who you ask, right? Americans will say Demeter and no? Okay, it's Demeter. Finally settled that. Sorry? Thank you. Oh, okay, cool. Demeter. Yeah, see, like yeah. Somehow always reminds me of Stranger Things. I don't know why. This is also one. Like basically says like if you have more than one dot in your reference, then that's a trigger. That's a heuristic, or a smell is probably a better word for that. Like context dot selected member path counts. So wait, so it's actually calculating the depth by taking something that looks like a string and counting the number of dots in there. Like that's a lot of knowledge. This is the same thing. So this should have already triggered the previous example that something is wrong. There's tons of examples on the internet. This is not new stuff. I learned this 20 years ago. I just completely forgot about that. One way of solving it is to encapsulate things. So here you have a first-class citizen in a code-based order, which has an internal or private order lines collection. I don't like classes which names is plural, but I couldn't come up with anything like that. I could have called it order line collection or something. But the special thing is now the logic of determining whether it's high valued is encapsulated inside that class. And even the top level one, the order, doesn't need to know how to do that. It just asks the underlying class. And I know everybody uses primitive types, lists, collections, dictionary stuff by default. By encapsulating those things into first-class citizens of your code base, so basically custom classes or types, it already makes your code a lot easier to maintain. You'll figure that out. If you do that, you'll discover that your code becomes much more readable. Because quite often, if you have like a parent-child relation, an order and order lines, the order is very bloated. It has a stupid list collection or something with order lines, but all the logic is in the order class. The order line is usually just 2 properties or 3 properties or something like that. Everything is in the parent class. That's the natural thing that happens. Apply, encapsulate primitive types. Don't do it always. Don't be dogmatic. But keep it in mind, every time you use a primitive type in your class, in your domain model, for example, would it be smart to encapsulate that? Like a string representing an ISBN number for a book. And then the class that owns that property of this field contains all the logic to verify whether an ISBN number is correct. Then create a freaking ISBN type for that. Encapsulate it. 15 minutes left. I'm halfway, I think. Dependency injection. Who's using dependency injection? Oh, okay. Everybody almost. Who has a global control? A global container. Okay. So that's another issue. If you have a global container, all your registrations are centrally somewhere. You have this big class where all the registrations of all your dependencies are happening. Interestingly, if you follow this kind of idea, and again, you don't have to call it functional slide, but just modules or something, it becomes also interesting to align those containers with it. Like this function slide has a local DI container. Maybe this composition layer has its own container for registering stuff. The third one has its own container. Maybe the second one doesn't even need a container. Why would you need it? It's only needed if you have complicated dependencies or something like that. Because, I've done this myself, like this huge registration class, and you try to make sense of it, becomes a mess. And at some point at runtime, you're trying to figure out, when you analyze the code, where does this come from? You know, it's hidden away with some, even worse, convention-based dependency scanning. Like magically things pop up. There is value in that, but you have to understand the flip side of that. It makes your code very difficult to understand. Aligning these with those internal boundaries is another great thing to do. And dependency injection, you don't need an interface or abstractions for dependency injection. You can actually inject a concrete class. Almost every example in the .NET space, the first people, what they do is, I have this component. What do? We create an interface called component with the I in front of it, and that's what we register. Why? Yes, because we need to be able to mock that dependency. Interestingly, if you use the same principles that I showed you as the unit of testing, you don't need mocking except across the dependencies. But inside, you don't need mocking interface. You don't need mocking libraries or anything like that. I'm not saying you should never use it. Again, there's two camps. No. Inside the boundaries, you probably don't need mocking tools. Across boundaries, you do need mocking tools because that's where you have your contracts. I hope the message actually comes across. So, of course, unless you're very lucky, you all have to deal with legacy code. It's not every project is greenfield. Even if you, I mean, I love legacy code. I'm addicted to legacy code. As I said, I love deleting code and rewriting it in my own image, but it's really nice. And I actually try to figure out, like, it's talking about legacy. Sorry, distracting this. I hope he's fine. I kind of try to imagine, like, because I have this natural way of approaching these legacy code bases, and I try to figure out, like, how do I actually approach this? What are the steps that I go through? Yes, sorry, now you're all distracted. I know that. Don't matter. Just listen to my voice. There's nothing on the slides. Listen to my voice and fall asleep. So I try to draw a little bit. In general, what I start with understanding if there's a production environment, what happens there? What is actually deployed there? What are the dependencies? What does it need? How does it run? Is it one machine? Is it multiple machines? Does it depend on cloud services? How does it scale? How do these instances communicate with each other? Which ports are opened up? That gives me kind of sense of what is the thing supposed to do and how it's being used in production. Because you can look at the code base, but this is very useful. That's what I start with. Then I try to figure out the code base. Is there a code base? What version is the code base? Is it which source control system is it using? I actually found, and this is not a joke, I'm not lying. This last year, I ran into a production system at a client where the code was actually on a network drive. In a folder. And there were also zip files containing alternate versions with that. And a zip.buck, backup, stuff like that. So this might be trivial, but even if you go to a GitHub repository, Azure DevOps, you might wonder, what is the version that's currently in production? What hash key is it? Do they use Gitflow or something like that? So that you immediately see master or main is supposed to represent what's in production, or tag or something. Can I actually go to the production executable and get the version or even the hash key of the commit from the production environment? If you can't do that, there's room for improvements. Next step, find that and then use code and delete it. Because again, all that code that you can delete, you don't have to maintain or understand. You can remove it. You can make your mental model a bit more simpler. Build a safety net. Unless you're very lucky, there's probably no automated testing or very limited automated testing or very unreliable automated testing. So build a safety net. Improve the deployability. If you start to improve this thing, how difficult is it to actually deploy it again in production? That's going to be interesting. Yeah, we do it by hand. What do you mean? Yeah, we create a zip and we copy it to a network drive, and then we zip into this folder, and then we change the config file, and we copy the original config file because it contains changes. You've experienced this, right? So use infrastructure as code, use Pulumi or something like that. And then, when you're actually capable of deploying a new version, start to improve the code quality. Start to apply the things I showed you earlier. Apply the law of Demeter. Look at the number of dots. Try to encapsulate primitive types with more specific types. Try to understand fit together. Then you even go one level up. You look at the code design. You look at the folder structures. And at some point, you may even look at the architecture. Can I actually decouple certain things? Is it actually useful to introduce an onion architecture or something, or apply the dip practice to make everything a little bit more loosely coupled? That on itself is a job. It's my job. So a couple of extra things. A safety net. There's a nice book written by Mr. Ferris. He lives in Miami Beach. Working effectively with legacy code. It's a brilliant book. It's written with C++ as examples. But yeah, if you do Java or JavaScript or TypeScript or C#, you'll be able to figure that out. And he talks about characteristics tests or characterization tests, which are literally tests that you introduce on an existing code base that call a particular method, verify or observe what comes out of that, and put that in the assertion. So literally writing tests that just capture the current behavior so that you can use that as a safety net, because then you're going to refactor and you know nothing breaks. Yes, they may actually work on a production backup database. Yes, they may be very slow. You will not be able to parallelize that. You know, they will be brittle, but it doesn't matter. It is something that you have. And you don't have to make it maintainable. They don't have to be readable, as long as and you can even, it's 2024, use an AI tool to generate some of that. That's a safety net. For example, I have this legacy code base, I have a production database, and I'm creating a bunch of test suite around that. That's what it could look like. What about this database? Well, it's actually pretty cool. These days, we have things like Docker, and you can run SQL Server, as an example, in a Linux container, which launches in milliseconds, and use that in your tests, so that a bunch of tests actually use its own isolated database, which makes those characterization tests a little bit more stable and reliable and faster. It looks a little bit like this. Linux test container, and then the test suite just creates a new one. Of course, if it's a production backup, you need to restore that, but you could even build a container that already contains the production backup in there and launch the container. It can still be pretty fast, much faster than having a shared SQL Server somewhere where you manually have to copy the production database. I've used this technique many times. It takes a little bit of work at the beginning, but it pays back easily. In the .NET space, it's actually called test containers for .NET. Okay, so how do you find existing seams and decouple them? There's a couple of things. I started with that. Use a tool to visualize things. I think most people are visual people, and we like to create this mental model, the best way to actually look at a picture. Then try to identify potential candidates for modules or functional slices. What I've often seen is that the original architect was actually pretty decent. They actually had some kind of architecture in mind. You know, there was some kind of structure in the code base, but the developers that came after that kind of lost track, you know, made a mess out of that. Not because they're bad developers, just because they didn't have this mental picture anymore and didn't know what to do. They just started copy-pasting code. Find types, classes, whatever you call that are supposed to be used together. That's important, because if they're used to, you can actually group them. Also find types that are designed to be reusable. That's a difference. There's a subtle difference. Something that's potentially reusable, which is practically everything you create, is something different from something that was designed to be reusable. Keep that in mind. When you see it, you know it. So these are just heuristics. It's not going to lead to guarantee you to success, but it hopefully gives you, gets you in the right direction. Bless you. And also look at the current dependency injection registration and see if that aligns with what you already seen. Because you're building this model, maybe you draw it out on paper or on a whiteboard or something like that, and then see if everything in the code base aligns with that. Quite often it doesn't, but looking at the registrations may actually, because that's code that doesn't change that often, may actually give you hints about what the original architect had in mind when they designed that code base. And as I said, code in adjacent folders, you should actually treat them as separate boundaries. Use that, you know, to visualize what the architecture should look like. Could be something like this, could be something else completely. Doesn't matter, but use that information so that everybody else also gets a sense of that. Or even use that and ask existing developers that have been around, like, do you recognize yourself in this? Well, not yourself, but do you recognize the code base in this? If not, you know, this only doing this because some of the developers may already have built some kind of mental model because they've been working with that code base. By creating this picture, they'll either say, oh, yeah, that's actually also what I have in mind. Or, no, man, this is completely not what this code base looks like. No, that's true, but that's a good thing. Pictures say 1,000 words. And then try to find some kind of code base that you start to untangle and create a nice separate block for it. How do you do that? Move code to functional folders. Step 1. That already helps me often. You know, functional folders with names that represent concepts from that code base, capabilities. Applied code level guidelines, introduce, for example, an editor config or ESLint or whatever you're using in that folder. Not an entire code base, but at the level of that folder, because that applies to everything that you move there. Start to clean it up. Use a dip adapter. What is a dip adapter? Well, let's say I have an order processing module, and I have this ugly generic interface, which you cannot easily change because it's used all over the code base. What you can do is introduce something in between. You define a new interface, a contract, which is very specific to the domain. That's new. The blue one is new. And then you have a simple class in the middle that implements the new interface as the dependency inversion principle tries to say, and has a dependency on the old interface. That way, you can have a small part of the code base define, become its own boundary, define what it needs, and have an adapter that actually translate that in the old interface. Because quite often, that iStore order, which only has 3 members here, in reality has like 50 members or something like that, because it just grew over time organically, because people weren't understanding the code base. That's a very powerful. That adapter is very small and is typically also not covered by tests, except maybe those characterization tests. Then duplicate code. Copy, paste across the code base. Copy, paste what's in that new little boundary, and copy there and make sure that it doesn't rely on anything else anymore. That feels very dirty. But also duplicate code that is not supposed to be used, but is used in multiple places. Just duplicate. And what you'll find is that by duplicating it, you can actually delete a lot of stuff. Because quite often, potentially or reusable code or code that's being reused is much more complicated than need be, because it needs to satisfy the different requirements of the different parts of the system. Just duplicate it and figure out, like, oh, I'm not using this entire path. Just delete it, delete it, delete it. And then you have 3 or 4 or 5 copies, which are much simpler to understand than that one reusable implementation. And of course, if it was supposed to be reusable and there's duplication and you think it's worth the effort, if it's really that complicated, as I said, move it to the shared service layer or whatever you call it like that, and start to reuse it all over the place. So it goes both ways. And I may be also looking at IOC containers. This is a very coarse-grained, high-level way of approaching that. The reality is much more complicated, but this is generally what I follow every time I have to deal with that. And then you just repeat. So you guys have this nice extracted capability. You know what's also cool about this picture? This is still a monolith, right? It's one application. Now imagine that this extracted capability needs to scale independently. If there's a reason to scale, not because somebody thinks it's cool, you could actually take that box, put it into a small orange other box, which you deploy independently in the cloud or something. And before you know it, you have a microservice architecture. The beauty is you have a microservice architecture that aligns with the internal functional boundaries of your code base, which is much better than a technical reason. But again, I'm not saying you should. You can consider that, given that you understand the consequences. Make sense? And then at some point, you have a beautiful code base, which will never happen because by the time you're done, you already moved to the next project. But that's the reality. That's the reality. This is it. Yeah, I actually caught up quite well, given that I lost a couple of minutes. I hope it made sense. Maybe not right now, but I hope that if you let it sink in over the weekend, or you drink a couple of beers tonight, it certainly will make sense. This has really changed the way I design and build my system. Every code base that I had to, help clients with, these were the things that helped me really. It helped me with applying test-driven development at the right level, dependency injection, dry, all these things align really well with this whole idea. So thank you for your attention. If you have more questions, you can stick around. Unless there's questions right now, forgot to ask, of course. If not, yes? Oh, yeah? Yeah. So you don't. So the question is, while you do that, you have like one group of people probably doing the new thing and the other people doing the old thing. I use a whip. No. Actually, I've actually used, I already told that yesterday, 2 days ago. I used to print out code and use a red pen to read. The thing is, a lot of developers either consciously or unconsciously start to mimic existing things. They copy what happens on the other place. Having this inconsistent scenario is not bad at all, as long as there's a path towards it. And what you will find is people get used to doing it in a different way. And quite often I've noticed this as well, that a lot of developers want to do it better, but they just don't know how to untie things from each other, or they don't know what pattern to apply to decouple things. That's your job as the person that does that. So it's not going to happen overnight. It can take a long time. What do you do about the religious debates? So I'm not a religious person. So yeah, usually you need somebody that has the ultimate say, because you will not always be able to convince everybody. I worked with architects with 20 years of experience that love to introduce tons of design patterns because it makes it easy to extend for the future. Yeah, it's a level of immaturity. Yeah, this is the difficult part. Even as a consultant, I'm running in a situation that it's sometimes not possible, difficult to convince. Then either you have to force it or you have to be patient. I'm not a patient person, so you guess what happens? No, it's not always working like that. So it's not a trivial answer. Good question, though. Yes. Oh, do one. You have 1 minute. Well, JSON that comes into the system is typically deserialized into a data structure, which we used to call a data transfer object, which can be a dumb object that just has fields, properties, and whatever. But it depends on the situation. I've actually had situations where I deserialized them into a data object, and then I still had methods on that object, so I don't have to deal with the primitive types anymore. But it's a very generic answer to a pretty generic question, but it's something to keep in mind. Don't be dogmatic. Maybe is that the only thing you need to remember. I'll be around. I also am available on lots of different channels. I actually think this slide deck is from a previous Star Wars focused presentation because I suddenly see R2-D2 and C-3PO. I'll be around for the rest of the day. I hope you enjoyed this session on Friday afternoon, which was a replacement session. Probably the original presenter was going to be much better. I hope you enjoy the rest of the conference. And I'm honored to be here. Thank you for having you all here.